Probably one of the most widely used applications of QuPath is for counting cells, and particularly for counting positive cells. So this is a key 67 example, and if I select a small region, so R for rectangle to help me draw that, and I will run then the positive cell detection command, which encapsulates all of the real steps that I need in here in one move. Okay. So whenever I run it, QuPath is then applied to cell detection within this region, and it has classified cells as being positive or negative based upon the brown staining. If I hyperpress F for fill, it will then fill them in, so it's a little bit easier to see what's being detected. And then D for detections will turn the cells on or off. And it's the same buttons up here. So F for fill, D for detections. And as it's done this, it will immediately tell me that within this region, it has detected about 12% of the cells are positive. So the reason I've chosen this region is I want a bit of variation to get some kind of sense as to whether the cell detection is operating reasonably across different cells in the image, cells of different appearance. And then from that, I can then go and I can see, should I perhaps modify some of these parameters? And so the first parameter, and often the most important, is the detection image. So you might recall that QuPath does stain separation using color deconvolution. So the detection image, the first option, is that it will use the hematoxylin image here after stain separation. And what you can see is that that is quite good for the negative nuclei, but it's a little bit weird in the positive nuclei. And that corresponds to what you see is a bit of fragmentation or weird shapes around the positive cells. So the other option I have is optical density sum, and if I click over here I can visualize it, and this is really eliminating the color information and just really caring about intensity. If I run the cell detection on this, then you can see that I'm no longer fragmenting the nuclei in the positive areas quite so much. And so I would say that probably optical density sum is giving me better results. If you look down here, when I try and do the stain separation, not so good. Optical density sum is better, I would say, in this case. But that's not going to be true for every image, and particularly if you're working with a positive staining which isn't nuclear, then optical density sum is probably not what you need. We have various different options that I described in an old video before. One that I'm going to change here is the requested pixel size, which is basically the resolution at which it runs at. If I increase this, it will run at a lower resolution, so the results may look less accurate, but they'll certainly be faster in a large region. And so by default, it's 0.5 microns per pixel. If I choose 1 micron per pixel, I think that's a reasonable balance between performance and accuracy. And again, because I get the preview results here immediately, I can see that there's not a huge difference in terms of the overall percentages when I change this. For any of these other options, I can put my mouse over them and I can get some more information. Sigma is going to be a smoothing related one. And so you can see if I increase that a lot, cells start to merge together. And so it can be worth adjusting these and seeing if it causes any improvements. One that I want to talk a little bit about is cell expansion. So QuPath is working by trying to identify the nuclei, and by tuning the cell expansion, I can adjust how far it can expand when approximating the full cell area. And that's useful if I want to, say, measure staining outside the nucleus. I can use cell expansion to constrain it to be a fixed distance from the nucleus. But in this case, I'm just going to leave it at the default, and you'll see in the next video why cell expansion, even if it's not perfect at approximating the full cell area, is useful when it comes to classification. And then finally, what I want to show here is this is the positive cell detection command, and that allows me to classify based upon a different cell compartment whether the cell should be considered positive or negative, so positive blue or red, negative and blue. And I can also adjust whether it's a single threshold or if it's multiple thresholds based upon staining intensity. If I want to adjust the threshold, I can do that as well. And so I'm going to leave it mostly at the defaults for now. I will then press backspace to delete my region. So that was purely for tweaking some parameters. When I'm relatively happy with the parameters, I can then choose a much larger region. I can press run, and then QuPath will break up the region into individual tiles. It will process them in parallel. So I'm running on quite an old computer, so it'll not be incredibly fast, but it'll process in parallel, detect the nuclei. It will try and resolve the overlaps between tiles to give something reasonable there. And whenever it's done processing, I will get then the nuclei across the entire region, which in this case is around about 100,000. For each cell that is detected, based upon the parameters I was adjusting, it has classified it as positive or negative, and it has also, if I double click on it, generated a long list of measurements, which we're going to use in a short time. But if I was to click on the overall annotation, double click on that to select it, I can see that immediately I have the percentage of positive cells. This is regardless of cell type, simply positive or negative. Or if I draw any annotation, QuPath will automatically be able to give me the percentage of positive cells within that annotation as I move it around the image. One last thing to note is if you've been using QuPath for a while, the version 0.1 or 0.12, it was very strict about where your annotations were. So if it was on the boundary, it wouldn't be able to say me how many cells were in this ellipse. That has been relaxed in the latest versions of QuPath, so that actually it's able to then tell me, based upon the cells that it sees within this region, even if you overlap the boundary of the annotation containing the cells, you should still get sensible measurements, which wasn't the true in the very first version of QuPath.